somewhere around 90% of those over the age of 60 have some sort of rotator cuff disease. So as the population ages, this gets to be worse. Now, most people think of it in terms of athletes, but athletes are only part of the problem. So right now what we're looking at is, and it's a little more than looking at, we've actually tried this, it's the idea of ultrasound elastography. And ultrasound elastography has been around a while, but not the way we're doing it. So traditionally the way ultrasound elastography works is you take ultrasound images and you kind of push on tissue, you push on the patient and you sort of see how the tissue deforms. What we're looking for is pure quantitative. Can we get real numbers to how rigid a piece of tissue is? Because you expect that in a tear, for example, you're going to have stiffer tissue or less stiff tissue. But our idea is building an ultrasound probe that's also force sensitive. So what you would do is two-stage. So you take an image, just touch the shoulder and then push a little bit and take the image again. And that gives you a length under no force and then a length over some force. The cool thing is, our idea with working with ultrasound and pressure, it's non-invasive. It's one of these things that I could take every baseball player before they pitch every game and screen them. And eventually know. So, it's kind of an interesting thing that, here we've got something that you wouldn't mind putting on, say, a child, but this is something that every doctor sort of can afford. And if they can't, a few doctors together can afford it. We think that it can very quickly get translated. It's not a terribly hard sell to FDA.